Today I am going to explain how we can use matrices and the matrix inversion methods to solve real-life problems. In this question, a local web company produces three types of packaging boxes: box A, box B, and box C. Each box uses different amounts of material: cardboard, plastic, and foil. So, we need to find out how many boxes of each type can be produced using the material available today. First, let's look at the material usage table. Box A uses 3 grams of cardboard, 2 grams plastic, and 1 gram foil. Box B uses 2 grams cardboard, 4 grams plastic, and 1 gram foil. For box C, it uses 1 gram cardboard, 3 gram plastic, and 2 gram foil. The company currently has 19 grams of cardboard, 28 grams of plastic, and 11 grams of foil. So, we need to translate this information into mathematical equation. So, we let x as the equal number of box A, y equal to the number of box B, and z equal to the number of box C. From the material, we form three equations. Cardboard 3x plus 2y plus z equal to 19. For plastic, 2x plus 4y plus 3z equal to 28. For foil, x plus y plus 2z equal to 11. Now, we have a system of simultaneous equations. Next, we rewrite the equation in matrix form: Ax equal to b, where A is the coefficient matrix, X represents the unknown variables, and B represents the total material. So, this will become our equation of matrix. So, this allows us to solve the system using matrix operations instead of solving each equation separately. So, now we are going to find the inverse matrix. But before finding the inverse matrix, we must calculate the determinant of matrix A. So, after expanding along the first row and then simplifying, we obtain the determinant to be equal to 11. And now we calculate the adjoint matrix and then we divide it with the determinant using this formula to find the inverse matrix. Finally, we multiply the inverse matrix with matrix B. We multiply and combine this value row by row to get three results: 33, 44, 22. These numbers represent the scaled-up version of our daily usage. So, by dividing each one with our determinant 11, this division reveals the exact returns used each day: 3 units of box A, 4 units of box B, and 2 units of box C. This means the company can produce 3 units of box A, 4 units of box B, and 2 units of box C. In conclusion, the matrix inversion method helps us to solve multiple equations in a clear and systematic way. This example shows how matrices we move to questions which use the same method. Now, I will explain how matrix inversion method can be used to solve a practical problem involving the watering schedule of herbs. A herb farmer records the water used on 3 different days for basil, mint, and rosemary. Although the total water used for each herb is known, the farmer forgets the exact amount used for each day. Our task is to determine how much water was used on day 1, day 2, and day 3. First, let's examine the table provided. The water usage pattern is for basil, it is 2 units on day 1, 1 unit on day 2, and 1 unit on day 3. For mint receives 1 unit on day 1, 3 units on day 2, and 1 unit on day 3. Rosemary, this is 1 unit on day 1, 1 unit on day 2, and 4 units on day 3. So, the total water used is 11 liters for basil, 15 liters for mint, and 21 liters for rosemary. And now, we define the variables. We let x equal to water used on the day 1, y equal to water used on day 2, and z equal to water used on day 3. From this, we will form the following simultaneous equation. For basil, 2x plus y plus z equal to 11. For mint, x plus 3y plus z equal to 15, and x plus y plus 4z equal to 21. This equation represents the simultaneous between daily water usage and total water used for each herb. And now we write the system in metric form. A S equal to B. So this is our present. Before finding the inverse matrix, we calculate the determinant of matrix A. So after using the zero matrix, the determinant is 70. And next, we have to find the adjoint A. So, this is our calculation for the adjoint A. And then, to find the liters used for each day, we will multiply it with the total materials. And so, it is what we got. And next, we will find the inverse matrix. And to do that, we have to divide the determinant with the number of liters used every day. So, what we got is on x, we have got 2, y is equal to 3, and z is equal to 4. This means that 2 liters is used on day 1, 3 liters used on day 2, and 4 liters used on day 3. So, in conclusion, the matrix inversion methods allows us to determine unknown daily water usage in a systematic and efficient way. These questions demonstrate how matrices can be applied in agriculture and resource planning to analyze recorded and solve practical real-life problems accurately. Thank you.
My name is and I'll be taking question 3, which means use a Cramer's rule. Okay, so the question is: a shop sells packs of herbs, thyme, and lemongrass, and lavender. One day, 3 different customers place order, each asking for a different combination of the 3 types of pack. The shop assistant needs to figure out how many packs each time are needed in total. So for the first order, we need 50 times plus 2 level grass plus 6 level. For the order 2, 4 times plus 11 level grass plus 3 level. And for the order third is 5 times plus 7 level grass plus 9 level. And then the question gave us to make the equation. So we transfer this data into the equation, and time we use t, level grass we use g, and level n we use l. And we make this equation, and this is how we answer the question A. Okay, now we move on to the question B. We need to use a Cramer's rule and to find how many bags of time, level grass, and level n are needed in total. So here we need to make 4 determinants, which means first determinant is in total, and second determinant for time, third determinant for level grass, and the fourth determinant is level. First, let's make one by one. So we take the equation for the total, we take the equation and transform into the matrix form, and we make this the equation that before, and then we make the follow based on the formula, while we take 50 and we cross them, we take this digit and we make times slash, which means 11 times 9, 7 times 3, and follow with the others. And then we get this answer, we minus them, and we get the answer is 966. So this is for the first determinant. Okay, and we move on to the determinant for time. So for the first step, we must remember our matrix form. Then we take, and then for the first is time. This is for time. This is for level grass, and this is for level. Okay, and then we take the total. We must hear the equation total for three material bags, and then we place at the first row, and the rest still same. Okay, and then we just follow up, just do the formula, the Cramer's rule, and we get the answer 8,694. Okay, and then we're not done yet. We must to remember back our total determinant is 966, and then our hands is 966, and to find the determinant for time is take the total 8,694 divided by 966, and we get the determinant for time is 9x. For the third determinant is for lemon grass. Okay, we still use the matrix form, and then now we use on the second row, we take the total bags, we place at the second row, and here we make it normal again. Okay, and then we just do the calculation, and we get 7,728. And now for the determinant, we take the level grass, 7,728 divided by 966, and we get 8 packs. And for the last determinant, we determine level, and now we transfer the total at the third row. And here, 181, 139, and 146, and the second row turns into normal. And we do the equation, and in total we get 4,830. And now for the determinant, 4,830 divided by 966, we get 5x. Oh, and we get the answer, time equal to 9x, level grass equal to 8x, and level for 5x. And then we change the name into the x, y, z. We form into the matrix, and we pull it out the answer into this. And this is how we answer the question 3. Okay, and for the conclusion, this question shows how Cramer's rule can be used to solve a practical problem involving a customer order organized way. This result shows that shop requires 9 pairs of thyme, lemongrass for 8 pairs, and lavender for 5 pairs to meet all the orders. Overall, this activity helps demonstrate how mathematical methods are not only theoretical but also useful in a real business situation, such as planning and ensuring customer demands are fulfilled. Thank you. And thank you for me. That's all.
Hi everyone. Next, my name is Mohammed Ismail. Next, now I will present you about how to do matrix using Cramer's rule. I will do question 4. So this is step 1. We need to set out the equation. So this is the equation that given in the question. So next, step 2. Finding the determinant of the coefficient matrix. So how to do this one? Okay. So I will explain one by one. First, we need to put all of this in one column like this. Like this. Next, we need to know that each of these have their main symbol. This one. So, next, we will count each of these questions. We will count the determinant of the coefficient matrix. So first one. So this one is for 12 and we use this one. So next. So this what we got for number 2. This one. We take this and this. And number 3. So it's all the answer for step 2. So next we move to step 3. So this is a bit long. This one is a bit long. The formula is a bit long. So step 3. Okay, you guys can see that we have the answer here. So we put like this for the N1. We do the N1 first for N1. Okay. So N1 equal to is 163, 41, and 128. And then we put this one, 7 to 9, 5.4. Okay, so why we put the answer for this at here? So we want to, okay, first we want to find the N1. So we take the N1. As you guys can see, the N1 is here, right? The straight line, right? So we put here, we change N. We change it. So this is the how to count it. Score minus so how we get this equation? Same like this. We take 163 and then we count this one first and then count this one, and the answer for this and this will minus it. So same goes to others. Okay. So you will do next. So you go to step 4, the final division. So we will take this. Oh yeah, I forgot. First, at this one, we need to count it. Minus 12 minus 28 plus 55 is equal to 15. So what are we going to do with this 15? First, we will count for n1 for the final division. What gram we will get? So, division 1, we will get 150 per get answer 15. And the answer for per one is 10 gram. We will get 10 gram for next one. Return to 60 per 15. We will get 4 gram. And return 3 45 per 15. We will get 3 gram. Okay. So this is the answer for each nutrient. So that's all from me. Thank you.